Welcome to the fourth module, Smart Contracts, the key to the Web3 architecture. Now that we know how Web3 architecture is built, we have the idea of a house with a foundation, the roof, the tunnel below it. Let's actually now talk about what enables the different layers to perform transactions and what sets certain rules for processing the data. We will start with the smart contract itself. You can think of it as a set of rules, exactly the same as when you want to rent a flat. When you rent an apartment, you always sign a contract with the owner or with the agency that is managing the flat. And this contract is listing the rules of the rental and requires both sides to agree to it, of course, after reading the entire document. In terms of the definition, a smart contract is a self-executing contract with the terms of agreement between peers directly written into lines of code. We will go through that definition slide by slide through some key characteristics, and we'll see how smart contracts work. So if this is still not clear for you, then don't worry about that. Key characteristics. What is important is that smart contracts are accessible. They are actually stored on the blockchain, and anyone can read any smart contract that was deployed. Moreover, anyone can write a smart contract and deploy it to the network as well. It's self-executable, which means that when the conditions defined in the contract have been met, the contract will execute an action. So let's say there is a contract describing a transfer of a particular token from one account to the other. And it says that if it's sunny today, I will send the transaction, send the token from Benny to Mandy. Of course, the smart tokens don't work well with the weather, but you get the point. And the action is the transfer of value that I just mentioned. And this is happening without the third party involved. So no bank, no financial institution, no government. Lastly, smart contracts are irreversible, which means that once they are deployed to the blockchain network, they cannot be updated and they also cannot be removed, which is different when we compare it to the Web2 ecosystem, where you can constantly update the code, you can remove the application that was deployed. But in terms of Web3, once the contract is uploaded to the network, once it's stored there, you cannot change it. The only thing you can actually do is to deploy a new version of that contract, which will have a different location in the blockchain. It will have a kind of like a different address within the network. And you need to make sure that once it's deployed, you're using the correct version of that set of rules that you just updated. As for benefits, first of all, smart contracts are secure. They are encrypted through different processes managed by the blockchain technology. And also the information they are processing, the results they give, are persisted on the blockchain, which means once they are stored in a block, they cannot be changed. So going back again to the immutability that we mentioned in the first module. Apart from that, they are autonomous. They are complete and they don't require any other third party for them to work. They cannot be changed by any other entity, any other third party. They are also interruption-free, which means if the conditions have been met and the contract started execution, it will have to finish. Then the contracts are also trustless. If you remember the definition of something being trustless, it means that we don't have to trust all the other participants of the network, and thanks to the clear conditions written in the contract, we are sure that the contract will be executed as it was mentioned in the encoded rules. It's also cost effective as the code is online and its execution doesn't require any third-party involvement of another entity. And also, the code is written in a way to optimize the processing of the data. So the developers are always trying to make sure that the way they structure code and how they compose certain objects, how they store the information, and also what information is actually persisted, allows the cost to go down. And lastly, smart contracts are known for their fast performance thanks to the logic written into the code and also the compilation process. So how do they work? I would like you now to imagine a vending machine with cookies, with Fantas inside, with water, whatever there can be in a vending machine. And how can we use a vending machine? Well, first of all, it would be good to know how it works. So there are certain terms and conditions of how the vending machine can be used. So what we know is that I need to put a coin inside and then press a particular number so I can receive the can of Coca-Cola that I want to buy. So if I actually do it, so I will put the coin and press a button. This is like an event happening. And these two actions will trigger the execution of the contract that we have with the vending machine, so that then the vending machine knows which product do I want, and as agreed, it will give it to me. So the execution is the process of giving the product. So once I clicked, the vending machine will execute the action. And this is also, again, coming back to the self-execution. I don't need to do anything. I just basically triggered a specific action, and the vending machine takes care of throwing that can of Coke to the bottom platform so I can take it out. In terms of smart contracts, this execution, this process will be written into the blockchain. So we'll be able to have a look at a specific block and a specific transaction and see what happened and what kind of value was transferred in that transaction. I've been talking about the theoretical details, about set of rules, about vending machines, but let's actually have a look at how a smart contract can look like. Following the link from the slides, which you can actually check out yourself later on, we landed on an Etherscan on the Search Passport NFT page, where we can actually have a look at the details of the smart contract. As you can see at the top of the page, we have the contract word here, and next to it, we also have a string of characters, which is actually the smart contract's address. Address being the location somewhere within the blockchain. If we will scroll down, you can see here different tabs. We have transactions, internal transactions, events, analytics, but what we want to look at right now is the contract tab. And within this tab, what we can see is the contract source code, which is written in Solidity. What you can see is the underlying code for the Search Passport NFT, which you can sell by checkout on OpenSea platform. And I can imagine that this is very difficult for you to read. There is a lot of code, a lot of those rules written in the code, and without any coding knowledge, it might be pretty intimidating. But what we will actually do in the next video is to first look at Solidity and understand some basic concepts, so that then what we can do is to have a look at the Search Woman contract and get a better understanding of what is going on here in the code. Before we dive straight into Solidity, I also wanted to tell you that Solidity is not the only language that is used for writing smart contracts. There is actually plenty of other options, some of the most popular being Solidity itself, Rust, or for example, Viper. And each of them is a bit different. It's built on top of a different underlying language and it's structured in a different way. However, I think that actually starting with Solidity would be the easiest path for you to understand how the code can be built, what are the different components, so that then later on we can read the contracts that are written on the Ethereum blockchain, which is using Solidity for its smart contracts.